Sheet number 3, problem number 3. This is the projection of line problem. So as we already discussed in problem number 2, you have to find out some of the data from the system, from the numerical. So first of all, true length, you need true length, a theta, phi, and a position with respect to HP or any endpoints, position of endpoints. So line UP 75 mm long, 75 mm long, that means true length is given to you 75 mm, and U is in the VP. So one position is given, that is in the VP, and 20 mm above HP, 20 mm above HP. Line is inclined to VP and parallel to VP, so parallel to HP. So the position of line or structure of line is look like this. If line is inclined to VP, that means it is in this direction and parallel to HP, so it is something like that. So this makes an angle with VP. So this point is U, because U is in the VP, and this is P. This is P, it is outside, it is on the air, and this U is on the VP. Find the inclination with VP. You need to find out this angle and inclination with front view as well, and front view measure is 65 mm. So here you don't have a theta and you don't have a phi, but instead of that you have two another datas, elevation length and plan length. If you don't have this angle, you have to find out for this elevation length and plan length. In this case, front view is given to you, that is 65 mm elevation length, and plan length is also not given to you. So you have only these three data and you have to construct a system. So first of all, draw a line, draw XY line. As you can see, point is in the VP, so you have to draw U is on the VP. So this is U, and 20 mm above HP, 20 mm above HP, that means this. So this point is U dash. So mention the dimensions as well. So this is 20 mm. So now we are going to use this elevation length. As you can see in a standard practice, elevation length is this, A dash B dash. If you project this point over here, you can see A dash B1 dash, A dash B2 dash is also elevation length. And here they ask that this line is inclined to VP and parallel to HP. So if you observing from the front, you can see only a straight line like this. So that distance is given to you. This distance is 65, which is given to you. So you have to measure a distance of 65 from this direction. So this point is your P dash. So now you can see U dash and P dash must be lies in a same line. Same way, P dash and P also lies in a same line. So you can draw a projections from P dash. You don't know the length of this line, or we can say this is your front view as well as elevation length. So front view or true length, this is your front view of U dash P dash, and which is called as an elevation length. You don't know the inclination angle or anything about this, but you know about 75 mm long, which is true length. So for true length, measure a distance of 75 mm on the rounder, put pointer on U and mark a distance on this projection line like this. So this distance, so this point is your P point. This point is your P point, and joint U and P, which gives you top view. top view of line UP, and which is and you can get this angle as well. You have to find out this angle, so you can measure this angle by using this method. So this is the problem number 3 from sheet number